And for distribution, for it starts from here, from this distribution substation. We don't do any work regarding transmission here. So it starts from a distribution substation, and then we have a feeder. A feeder, we shall look at its definition, but generally it's just a passage of of power from a distribution substation to a distribution transformer. We shall look at it. That is called a primary distribution. Then from this transformer here, these are just transformers that you'll be seeing on pole structures, the ones that supply us. These small transformers here. From the distribution transformer, we have what we call the secondary. The secondary distribution, it starts with the transformer. And the secondary distribution is where we see low voltage. When I go on the next slide, you should be able to remember this distribution substation. You should be able to remember the feeder, and you should be able to remember where the transformer was and the distribution service mains to the consumers. Now, to understand this well, we shall come here. Electric power distribution system. I have told you it has a primary distribution and a secondary distribution. I know most of you have done some industrial training with these distribution companies. It may be somehow obvious for you, but even if you had never, maybe you have been in industries, you can pay attention and try to pick these things. I said primary distribution is the passage of power from the substation, a distribution transformer, and from there, it is always supplying a three-phase, three-wire system. There are always three wires, and they carry three-phase, three-wire system. It operates at a relatively higher voltage of 3.3, 6.6, 11, and 33 kV. Now here in Uganda, we use 11 kV and 33 kV. Generally, these are the feeders that the distribution companies use here in Uganda, 11 kV and 33 kV. We are from the substation now to the transformer. It is 11 kV and 33 kV. This supplies large consumers like factories and industries. Before we come here to secondary distribution, which supplies residential consumers and commercial buildings, you must note it that also 11 kilovolts and 33 kilovolts, there are also consumers that use this voltage directly, like industries and factories, because they have machines that need 11 kV and 33 kV. They cannot use unbalanced voltage. And this 11 kilovoltage and 33 kilovoltage, we call it balanced voltage. And there are some machines that cannot use unbalanced voltage, and therefore they have to use direct 11 kV or 33 kV. In industries, there are some machines that use this voltage directly. When you come to secondary distribution, it has 3-phase and 4-wire. I have some pictures down here we shall see. For 3-phase, 3-wire, they are always just 3 wires up, and they are always moving horizontally on the top of poles. But these ones, they are always in a vertical structure when they are moving, this 3-phase, 4-wire system. And this operates at a low voltage of 220 to 240 for single phase, and 415 to 440 for a phase to phase. That is 3-phase supply at a low voltage. When we come to this Electrical power distribution system, a distribution substation. Here I have a few definitions. It just steps down high voltage from transmission to primary, as I told you. I told you that feeders, their passage of stepped down voltage to distribution transformers from the substation. We have distribution transformer. Now, this distribution transformer, these are the usual transformers that are in our areas of localities. You find a transformer hung on poles. These are distribution transformers. We have a distributor conductor. Now, a distributor conductor, it is an output after the transformer, where I was explaining the secondary distribution. That's where we find the distributor conductors. These are conductors also on poles. When you see them, they are always in a vertical structure. They are not horizontal. So these are distributor conductors. But from distributor conductors, on that pole where the meter is, the meter that supplies in your building or in your commercial, there are service mains conductors. Those who have worked with distribution companies, in the layman's language, it is called the solder wire. You will hear people call them solder wires. These are service main conductors that connect now from the pole to the building. I'm explaining all this because there is no way you can do maintenance when you don't have a clue on what you are maintaining. When you see this electrical power distribution system, I tried to get some pictures. This is for primary distribution. 3-phase, 3-wire, carrying 11 kilovoltage or 33 kilovoltage. Whenever you see a structure with pin insulators like these ones and their wires passing on the top horizontally, you see this picture here. When you see this conductor, by the way, when I'm talking about the conductor, I mean wires. Whenever I talk about the conductor, I am meaning these wires that move on poles carrying electricity. So when you see this conductor, when you see this conductor and you see this one, they are horizontal. They are moving on the top of the cross arms. This is called the cross arm, and this is called the cross arm. You see, this wire is moving on the top of the pin, and this one is moving on the top of the pin. So whenever you see this structure, where there are 3 wires moving on the top of the pin insulators, just know that is 11 kilovolts or 33 kilovolts. Apart from a structure that looks like this, that means that is going to be secondary distribution, and those are the conductors that are carrying electricity from the transformer, from the distribution transformer, and they are always moving in a vertical way. So if there was a transformer here and we want to see the distribution, the low voltage conductors, for them they move like this. Remember, for them they are always 4. It is 3-phase 4-wire because they have a neutral, but these ones don't have a neutral for 33 and 11 kV. A transformer receives a 3-wire 3-phase, and it outputs a 3-wire 4-phase, like the ones I've drawn here. This is always alive. This is always alive. This is always alive. And this is always a neutral. This one that I've drawn here is what we call the secondary distribution after the transformer. We get 3-wire, we get 3-phase 4-wire. But before the transformer, it is primary distribution, and we have 3-wire, 3-phase. It feeds the transformer, and the transformer outputs 3-wire. it outputs 3-wire 4-phase as I've showed you here. And they are always moving in a vertical structure like this that I've drawn here. Maybe apart from the new conductors that have come that we call ABC, they are called aerial bundled conductors. When you look at it, you may think it is just one black wire up there, but they are always 4 wires coiled. For them, they are insulated, and when you look at it, you may think it is just one wire, but they are always 4. So this pictorial, I think it can help us to make a picture of a primary distribution and a secondary distribution. That is before the transformer and after the transformer. After showing you that pictorial for a primary and the secondary, I am interested in a transformer now, this distribution transformer that I've been talking about. There are very many things, but I tried to pick this transformer because it is also very main. Now for this transformer, I want us to look at it and know that this is the transformer that is always hanging our braces of localities and supplying us. It has different parts as you see them here, but I'm very much interested in a few that I'm going to talk about, because if you don't understand this, then there is no way you will understand maintenance of electrical distribution, because most of the maintenance happens on this transformer you see. It has this part, this, and this. These are called bushings. They are called high voltage bushings. These ones, the tall ones. When you go out there, you will look at transformers. For them, they are always tall, but there are also other small ones. This one, this one, this one, this one, and this one. You see, for them, they are 4. As I told you, a transformer receives 3-wire, 3-phase. That is 11 kilovoltage or 33 kilovoltage, according to the rating of the transformer. And when those wires come, they feed here on these bushings. And then the secondary distribution will come out from here, from this bushing, from this one here, from this one here, from this one. These bushings are made of it is called primeric. You know, like these cups we use for tea. I don't know whether primeric is like clay, but it is non-conductive. It's insulating. Power cannot pass through it. And their importance is to allow a connection to this transformer. Because you see this transformer, it's metallic. There is no way how we would have 11 kilovoltage now being fed to this transformer. How? There is no way. And the only way is to provide these insulating materials called bushings. Because you see at the top there is a metal. Now it supplies it, it separates this power, this voltage that is entering from this metal casing. Otherwise, there is no way how we would get power out of this transformer or feed power into the transformer. Then we can look at other parts now. We have the bushings, I have explained them. We have the thermometer for temperature. We have oil gauge, this is for oil, to know the level of oil. We have the explosion, we have explosion vent, we have a conservator tank, we have a breather, we have a batch hose relay. A batch hose relay is always in this, it is connected to this conservator tank, and its importance is to determine any anomalies or faults that are happening inside the transformer. Anything that happens, then this virtuals relay will show. We have the radiator, we have the main tank, and we can look at their importance, the bushings. I have said they provide insulation and sealing. Conservator tank, oil expansion and control. The breather is for moisture absorption, air filtration. We have the radiator. The radiator is for cooling surface area. There are many machines with radiators, like generators. Even in the cars, we have radiators. So this is cooling surface area. Batchwords relay fault detection. A batchwords relay is a protection scheme, and its importance is to detect a fault in the transformer. We have the main tank. Now the main tank is to cover all the inside parts. We have a thermometer, temperature monitoring, we have oil gauge. This oil, it is for oil level indication. We have explosion vent. This is for pressure release safety. It is also a protection scheme. We have a tap changer. Now a tap changer is for voltage regulation. The tap changer, there is a way it is connected inside, and it has taps on the winding. So if the voltage that is going out is low compared to what is needed, then they can use the tap changer to change on the tappings in order to increase it. Okay, so at least that is an overview on a transformer. And in case when I'm explaining and you feel you want to understand something, you can speak and you ask a question as we move. You don't wait until the end to ask. I have terminologies to put across. You need to understand some things. Before the terminologies, I have a small picture here, which is showing us that the distance between the poles is called the span. And we have what we call a sag. A sag is from this, the expected horizontal line between the poles and this. If these are conductors, then we calculate we say that this is a sag from here up to here. Or if you want to know the sag, when we are doing a calculation about the sag, we measure it from here. So the sag is this. We have the ground clearance. Now ground clearance is from here, from the conductor to the ground. That is the distance. Actually, many people misinterpret ground clearance and they think it is this activity of slashing around the line or the line structure, but it is not. Ground clearance is the distance between the conductors and the ground, and this is the conductor. Generally, as I've explained that picture, if you are on seeing it, we have the overhead line. Overhead line, these are conductors or the wires carrying power or voltage. We have a span. I've explained the span, that is the distance between the pole and another pole carrying voltage or electricity. We have a conductor sag. Now a conductor sag, I explained it, that it is the natural downward curvature or dip in an overhead electric wire between two support points. This is caused by the weight of the wire and environmental conditions. It must be properly managed. Now, when we are looking at maintenance, all these things, they are the things we'll be maintaining. There is a conductor sag for low voltage, that is in secondary distribution after the transformer, and there is a conductor sag for for primary, that is 11 kilovoltage and 33 kilovoltage. In case there is there is a variation in the sag that is supposed to be for 11, then maintenance should be done. You go and do what we call stringing. You string to make sure that you put up the sag to its normal. We shall look at that at the end in maintenance. We have an intermediate pore structure. It is also another terminology. When I talk about an intermediate pore structure, you see when you look at a line, whether for secondary, that is low voltage, or for primary, for high voltage of 11 or 33 kilovoltage, all these structures have what we call intermediate pore structures. Now, intermediate pore structures, for them, they are always they are not at any angle. Some of them, I showed you the pictures that the wires are passing on top immediately. So that means that even if they remove that intermediate pore structure, the line would not fall down. No, it remains, though the sag increases. That means that the pore structure is not at any angle. I don't know whether you understand me there. If this is a pole, and this is a pole, and there is another pole here, and there is another pole here, and power is running from here up to here. But when it reaches here, there is, so I'll say this is a pole, this is a pole, and this is a pole, and this is a pole. When I talk about an intermediate pole structure, I mean a pole that is here at the center, whereby the conductors pass at the top without any angle. That means that even if they remove this intermediate pole, the power line continues, but the sag increases. It almost touches the ground, but the power line does not fall. But there is this section here, which is at the angle, this one here, because you see, it is taking now here from here. Now we call this one a section pole structure. This one is always at the angle. And before we continue, actually, when I'm explaining this, it means I'm explaining very, very many things. We may reach on the side, and I have already explained it. When you see this section pole, it means it has many forces. There is a tension taking here. There is a tension here. So it means after a while, it can be pulled this side. But what do we do in order to make sure that it is not pulled here? We put here what we call a stay. A stay wire is a support. There is that wire you always see. It is always grounded also. Okay. Now this is a pole. Let me explain this one from here and we finish it from here. You see this stay wire here, it is also a terminology on its own. I was here explaining the intermediate pole. I explained the section pole, which is this one. Now I'm explaining about the stay. A stay wire, we have different types of stays. We have this one that you always see from here up to the ground. This one is to protect this pole from being pulled inwards, because you see there is a tension here and there is a tension here. Here we put what we call a normal stay. This structure is supposed to have a normal stay, which is from up on the top of the pole to the ground. And it has, I think it has a formula. If I still remember well, for a normal stay, if it is LV, then it is It is how much? Is it 3.3 meters? 3.3 meters. 3.3 meters from the pole here to where the state is. That is supposed to be around 3.3. Because the formula of getting it is 1 over 3. It is a third times the height of the pole. Now the height of the pole for secondary distribution, that is low voltage. These poles are always 9 meters, 10 meters, and sometimes when the topography of the area maybe it is like a valley, it goes to 12 meters. So when you get 1 over 3 times 10, which is the normal, when the topography is, if it is a flat area, 10 times this one, I think you are supposed to get around 3.3 meters. I think this is the formula we use. But normally when you go in the field, this guy will tell you it is 3.3. They actually speak it in feet. You put 3.3 and maybe he doesn't know that it is by formula. It is 3. This is the same formula that works for HV. That is the primary. And for HV, they are always somehow high because they use poles of 14 meters. And sometimes maybe when the topography is okay, they use poles of 12 meters. Still the same formula applies. I'm now calculating the distance here, which I may call x from the pole up to here. That is the standard of a stay. A stay is that support that is trying to support the pole not to fall down because of the tension on it. And now these days, when we are building lines or when we are maintaining, you realize that people have refused. You cannot put all these three. The person allows you to put the pole in the land, and again you want to again stretch this and put this. So sometimes these people refuse. And in instances where a person refuses, that he doesn't want much of his area to be filled with this structure, we use what we call an outrigger stay. An outrigger stay, it has an outrigger bracket. An outrigger bracket. It is always a triangle like this one, but inverted on a pole. Let me see. It is always like this. I think if I'm not forgetting, if this is a pole, then there is a wire passing up here. Now this is a stay. This is a stay. Just because it has an outrigger bracket, it is called an outrigger stay. This stay would have come this side from the pole up to here because of the standard distance for it. But because this person doesn't want much of his area to be covered up, we use what we call an outrigger bracket and we use an outrigger stay. And therefore, the stay just remains near the pole. But it still protects the pole at the same rate as the normal stay. It is not only when people refuse, but when you find that the pole is like near the road, and when you calculate the distance that is supposed to be standard for the stay, you find that it is supposed to be pinned in the road. There we use what we call an outrigger stay. Now, there are instances where you find that even this distance is not there for an outrigger stay. This one is not there. What do you do? There is what we call a flying stay. Now, a flying stay, for it, if this is a pole, okay, this is a pole, which is like this one on a section, and the stay is supposed to come from here to here. That has refused because maybe this is a road. Okay, even the outrigger bracket that would have come here, the stay would have been like here after putting this bracket. Even this distance is not there. And the pole is here. So what we do, if it is like a road, we put what we call a flying stay. And the flying stay just moves across the road up, and then you go and put another pole on the other side of the road. This is a conductor. You put a steel conductor, not aluminium, a steel conductor for its strength, because for it is strong. And then after putting another pole on the other side, this pole you again give it a normal stay, which will support this. Now I have explained an outrigger stay. I have explained the normal stay, which has a standard distance from the pole. I have explained a flying stay. That is in instances where it is like near the road, or maybe you find the line is supposed to pass on someone's house and there is no this distance. You put another conductor up and then you go and protect it from the other side. I want to explain about another stay and then we finish the stays. There is a stay called a guy. A guy. It is called guy. We have what we call a guy stay. Now, a guy stay, for a guy stay, it is under compression, whereby you find that all these options are not there. Even if we would do a flying stay, the other side there is no place where to put it. An outrigger stay, for this, it is not there. We don't have. So we now come here inside this and we put a pole to support this from, we put a pole here like this. In order to support this pole from this tension and this one, now this pole, for it, it is under compression. You get? That is called a guy pole. It is also a stay. They are like these stays we use to support the matoke. If you guys know the banana plantation, there are these stays that we use. So it is like that. It is called the guy pole. If you are noting, you must note that we have an outrigger stay, and that one uses an outrigger bracket. That welded metal you see up, it is at the angle of 90, 60, and 40. It is up, and this stay is passing through it. That is called an outrigger stay. We have a normal stay, and we have a guy pole or a guy stay. That is the one that we put inside in order to support the pole in case the other options fail. So I have explained a conductor sag, I have explained an intermediate pole, I have explained a section. This is a pole at an angle. I have explained the ground clearance. Ground clearance, I told you, it is just the distance between the conductor and the ground. So guys, let me hope you're on and we are moving. Whenever you see those wires, just know they are called stays. And the stay also has a lot of accessories, very many. I think if we get time, we shall talk about it. Someone should remind me, maybe talk about it at the end if time allows us. Another terminology is load shedding. When you hear about someone talking about road shading, what does it mean? Now, road shading is a situation where you find they are isolating some lines, leaving other lines on. This is because of maybe low power supply or maybe of emergency or maybe of they need critical switch off some other people such that power remains stable supplying the intended consumer. You realize that sometimes when a person like the president is in an area, you find they switch off some other areas and they leave power to that area where the president is. So we call that road shading. And sometimes when you look at the definition, they say that emergency services such as hospitals, fire services, important government offices, and many others are left out, and load shedding is carried out phase by phase. Okay, so you shouldn't get confused when you hear a person talking about the word load shedding. That is actually what it means. You isolate some parts and leave other parts on. We have some materials and accessories. We have poles, or what we call supports that I've been talking about. And here we use wood. I have never interacted with concrete, and neither have I ever interacted with steel. I have been interacting with wood. These are the poles I've interacted with, but they are all poles and they are supports. We have conductors. We have what we call an aerial bundled conductor. This is a new conductor. New conductors, they have just come of recent, but otherwise we had their conductors, the ones I showed you that are always on a pole. That is a secondary distribution after the transformer. This is always a red wire. This is always a yellow. This is always a blue, or we can call them live, or we can call them hot wires. And then this is always earth wire. So I told you they are always moving in a horizontal way like this. So this is at a secondary distribution after the transformer. These are called Bayer conductors. But there are new conductors called aerial bundled conductor. You will hear people call it ABC. Now these ones are insulated. When you look at this conductor, you may think it is just one wire on the and you will wonder, but how? Is it one wire? But there are always four wires as you see them here, coiled together, and they are always labeled, not necessarily A, B, C, but they are always labeled, and therefore you can differentiate and know that this is a phase, this is a phase, this is a phase, and this is a neutral. So you see they are saying ABC cables are overhead power lines using several insulated phase conductors bundled tightly together. This cable consists of four conductors, whereby three phase conductors and a neutral, which is big in size. Yes, sometimes not every ABC has this characteristic that the neutral is big, but they are always labels. You find like N, then you find like live. When you are working on the structure. So aerial bundled conductors, you should actually after here go and search about them. They are very important and they are very, very expensive. You will hear people being imprisoned because of stealing them. They come at night and they start chopping them off because they are very expensive. Just 1 liter of this conductor is very expensive. So people come at night and they switch off power, they cut them off and they try to take them. Why? Because they have importances like they are friendly to the environment, they don't cause severe accidents. When these bare wires fall down, imagine like kids are coming from school, many of them will die from these conductors because they are live. and they carry power. But this one, even if it falls down, it is insulated, and therefore you cannot have severe accidents. Even if kids come and touch, before the team that is responsible comes, uh, they will they will find when the area is okay and it is not affected, like these ones. The other thing is that it needs less structure. For these conductors, some of them they need insulators. We are going to look at what we call a real insulator. A real insulator. Now these ones you see here, they use real insulators. That is how they are connected here. A real insulator is always connected in another metal called a D ion. A D ion. These guys will call it a D ion, but it is called a D ion. And through that real insulator, that is where this touches. Now imagine this is 1, 2, 3, 4. They all need real insulators. Hmm? So you find that this structure needs a lot of accessories than an area bundled conductor. And that makes an area bundled conductor better than this. In very, very many ways, you can search about it and see how important it is from these other bare conductors. We have aluminium conductors. Aluminium conductors, different types and sizes. They are used for drawing overhead lines, whether they are low tension or high tension. Something I didn't talk about is high tension and low tension. When we talk about low tension, generally they are meaning low voltage. That is at the secondary distribution after the transformer. Then high tension, they are meaning from the substation to the 33 and 11 kilovolts. So when we talk about ASC, aluminium conductors, these are conductors that are used up and they are made of aluminium. You will read through this and see. Then we have aluminium conductor steel reinforced. Now this aluminium conductor, it is aluminium, but it has a steel strand inside. Because steel is very strong for its strength, this conductor is made in such a way that we put at least a strand of steel inside in order to increase on its strength. But much of the strands on the top are aluminium because aluminium is much more preferred for distribution and transmission. You will not see anywhere where they use a steel type of conductor to distribute or to transmit. Maybe what I didn't talk about before when I was talking about steel, the other stays, those supporters that I was explaining at the beginning, they are made of steel. All those stays, they are made in steel. Now, not aluminium. Aluminium is always up. I don't know whether when I'm talking about aluminium, whether you understand it, but some of us who have saucepans that we use to cook, some of them are made of aluminium, and that is the aluminium I'm talking about. But still, this steel here, for it is not like aluminium, but it is used now in stays. All those stays that you see, all the accessories, let it be the turnbuckle, let it be the running bracket, the stay wire, the pole top make off, all those accessories of the stay, they are made of steel. Okay? So that is aluminium conductor steel reinforced. I'm sure you studied these things in power, like power one. Then there is all aluminium alloy conductors. So that is also, it is called aluminium, magnesium, silicon alloy, and it is called an all aluminum alloy conductors. But sometimes this is not much used. I don't know why, whether it is because it is expensive or what, and you will see they will tell you it has an excellent sag tension characteristics and superior corrosion resistance. These ones are not used. Maybe they are very expensive, but I've not seen them being used. When we look at the pictorials, you see this is this is this, and this is this. Okay. Uh, this is uh, this is a reinforced. It has a steel inside. I think you can see this car. I think this one here inside. This is to provide strength. Then this one, I explained it. And this one is always like this. You see, for it, it is pure. It is aluminium. When you look here, they are not like these ones. Okay? We have materials and accessories continued. We have pin-type insulators. Pin-type insulators, these ones are for 11 and 33 kilovoltage. In the first pictures that I showed you wires passing on top. Those for 11 and 33 kV. Now, those wires are always on a metal, which we call cross-arm. Let me try. Now, we have some insulators here. Okay, so when we have, this is a pole, let's say it is carrying 11 kilovolts. I have remembered something else. Let me also explain it when I'm here, such that I don't forget. This is a pin insulator, this is a pin insulator, and this is a pin insulator. Okay. You see where the pole is? Let me hope I have some people in class.
Yeah.
So you'll find another pole here. Okay. You'll find some other pole here. This is how a structure looks like. So they are continuing. Let's say this is an intermediate and this is an intermediate pole. You see how it is? Two of the phases they are on the side of the pole here. The pole is here, the pole is here, but these two are passing here. Okay? One is passing the other side. Now, when they reach on another pole here, this one will, it changes and passes the other side of the pole, and now one passes here. I want you to be critical when you go out and look at those poles. You will see what I'm telling you. There is a reason. The pole is here, one is passing here, now these two are passing here. But when you reach on another pole, now they will, this one, we shall put it to the other side, such that now two pass the other side and this one. And they go, that is how a structure moves. Why? Because remember, these ones are carrying a lot of voltage. That is 11 kilovoltage or 33 kilovoltage. And the moment they don't maintain a standard distance in between here, then you know there can happen a problem. So here it is a small distance than this, but here this one will be bigger than this. So that is how it moves. Here I drew this when I'm going to explain pin insulators. Those insulators, they are made in a material that I explained at the beginning for the bushings of a transformer. They are all made in the same material. It may not necessarily be the same material, but you can get it somehow like that. They are always like clay-like material, and the importance is for 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 insulation. Should I say insulation or because they are bad conductors, and therefore when it is passing on top, remember this is a metal. What would happen? It will be a total short circuit. But now they are passing on the top of these pin insulators, and these are what we call pin type insulators. Then we have the real insulators. Now these real insulators, they are the other ones I explained when I was explaining on the secondary distribution, and I showed you when I was comparing A, B, C with the other bare conductors. I said the bare conductors maybe need much accessories, and I mentioned a real insulator. That is where real insulators are used on LV. You see here they are talking about it 240 to 415. That is in the secondary distribution. Okay. We have disc type insulators. These ones are also used uh, in in 33 and 11 kilovolts. Disc type insulators and pin, they are used in different structures of 11 kilovolts and 33 kilovolts. That is at the primary distribution from the substation to the transformer. And there are also very many structures of which maybe you're going to search about. So when I talk about a real insulator is this one here. This is for LV. Now you see this is called a D ion. This is called a D. This is called a D ion. Mhm. So this one is always at the pole. Let's say this is a pole. In here there is what we call a bolt. Sometimes they put what we call an M16 bolt. They put an M16 bolt. That is how the bolt is called. The one that touches this one now into the pole. Then a conductor passes here. Actually, it is not a conductor that passes in here. What passes in here is called a dead end. It passes in here. It's a small wire made of aluminum also. It is called a dead. It is called a dead end. Okay. This dead end is somehow coiled. So when a conductor comes here, then it coils around with it and tightens it. Okay. Now this is for LV. What passes in here is called the dead end. And what passes on the top of the other 33 kilovolt, they are called jumper wires. They are also in aluminum. They are called jumper wires, aluminum. So they serve the same purpose like this dead end. I showed you these pin insulators when I was drawing some time back. I showed you this. These are pin insulators. Then we have disc insulators, which serve the same purpose. Okay. I see time and I need by 40 minutes to have finished, and then we can have an interaction. We have electrical power distribution maintenance. We have now finished the accessories, now we have started the real maintenance. So maintenance of power distribution takes most of these forms. We have preventive, not going to speak much about preventive, but here you do regular inspections in order to prevent the likely happening of faults or anything, any anomalies that may disturb the continuity of power. That is called preventive maintenance. Then we have predictive maintenance. Predictive maintenance, we use the available data for forecast maintenance needs. Here you see they're telling us we consider factors like temperature, vibration, eh, and usage patterns to prevent power interruptions. Now here you listen to how the transformer is vibrating. You listen to the sound. That vibration will tell you whether there is need for maintenance. That is what we call predictive. You predict and be like, but the way this transformer is vibrating, what the sound it is producing, then there is likely to be a problem. You don't wait for the problem to happen, but the team comes and works on it. Okay? So that is predictive. Then we have corrective maintenance. This one, this maintenance happens when an issue is noticed. When there is an issue, there is a power shutdown somewhere, then here we call it corrective maintenance. Then we have what we call condition-based maintenance. This occurs when a situation or a condition indicates maintenance is needed. It is almost the same as corrective, but this one is corrective, it is an issue has happened. Condition-based maintenance occurs when the situation or condition indicates maintenance is needed. When there is a condition, for instance, when I was explaining about the transformer, I showed you that it outputs three-phase, four-wire. Now the fourth wire is a neutral. That means that if there is what we call unbalanced load or no load balancing. When you are supplying a customer, you supply him with one phase and a neutral. You find some customers are connected on red neutral, red neutral, red neutral. Others are on yellow neutral, yellow neutral, yellow neutral. So at some point you will find that one of the phase is overloaded. And all those people that are supplied by that phase, maybe sometimes they start dimming, okay? But others are writing well. So that is a situation or a condition people are complaining that they have dim light. Then as a team, you have to come and know why. If the phase is overloaded, then you remove some customers and put them on the other phase. Then we have reactive maintenance. This occurs when a total breakdown or a failure appears. Okay? So those are some of the forms. From that, we have what we call safety measures during maintenance. This one I will emphasize. Here you can lose your life if you don't maintain this. Now, safety is very key in every engineering discipline for protection of lives from electric shocks and sharp objects and equipment from damage. Before we continue with safety measures, I want us to know about the hazard and the risk. When a person talks about the hazard and the risk, this one you need to get it because this one even appears on on interviews. They will ask you to differentiate between hazard and risk. Now, hazard is a potential source of a situation that has the capacity to cause harm or an adverse effect, e.g., exposed live HV wires, which causes a risk of electric shock and serious injury to personnel. That is a hazard. But a risk is, let me call it like the probability or the likelihood of a hazard happening. Okay? Because it is saying that a risk refers to a likelihood of an adverse event occurring due to exposure to a hazard. In the context of electric power distribution maintenance, the risk associated with the above mentioned hazard is high when workers come in close proximity to the live wires without proper safety. Now, a person coming closer to the live wires We call that a risk because there is a likelihood, the likelihood of him getting shocked, which is a hazard. That likelihood is called a risk. Now, if you identify a sag in the secondary distribution, you see these things I'm drawing here. This is live, this is live, this is live, this is neutral. But these wires are not always straight, the one I'm drawing there. They have a recommended sag, so they are always, they have a sag. Now, when a sag increases, there is that likelihood that a phase may come into contact with this is called a risk. Because when they come into contact, then we shall have a short circuit. Now, what a short circuit does will be a hazard. But the likelihood of this coming into contact with this is called a risk. A risk is the probability of this one coming into contact with this. But what happens after is called a hazard. So you need to maybe read much about this, the risk and the hazard, and wait, because it is very important to differentiate them when we are doing maintenance. We have safety measures during maintenance. We have the PPE. We have the hard hat, that is the helmet. We have gloves. We have long sleeve. We have approved safety boots. All these are PPEs, and in safety, you need to have them. Safety measures during maintenance. We have safety measures during maintenance. We have training. The personnel or the team that is working needs training to know what it is doing. We have warning signs and barriers. Every pole that you see, it must have a plate, a danger plate. You'll find hatari. We need signs for safety to know that this. You see, that is why when you look at our Chumro building, when you look at the distribution boxes inside there, you will find somewhere like high voltage, and there are some cartoons showing you that it is high voltage. When you touch it, you die. In other words, that is not high voltage, by the way. As engineers, we should know that that is not high voltage. Any voltage that is below 415 is not high voltage. But they put that in order to scare away people. Because that voltage, even if it is not high voltage, as they put, it kills you. Oh, it can kill a person. That is why you will find high voltage, don't touch, warnings and signs and barriers. Regular inspection. Conduct routine equipment inspection to identify address potential safety issues before they become critical. That is regular inspection. We have grounding. When we talk about grounding, all electrical equipment systems should be grounded, and we all know that so far. We have safe lifting practices. When we are doing maintenance, we lift poles. Sometimes we lift poles, we lift transformers. The transformer is very heavy. You have seen in mountainous hills where they are like, I remember one time we carried a transformer, a wheel where there was a mast, they were constructing a mast. And we had to carry it like 50 people. So if you don't take some precautions when they are lifting and those people are singing their songs, you may end up getting injured. So you need to take caution about that. We have emergency procedure. Emergency procedure, just of recent, like 4 months ago, I don't know whether you guys were in a holiday or we are here, someone tried to climb on an electric pole of 33 kilovolts here in town opposite Amazon. I think he was mentally disturbed. There is what we call an emergency shutdown. And an emergency shutdown is done when there is an emergency. Because the moment they realized this guy was climbing on the pole, They called immediately in Kampala and they did a remote shutdown. Someone in Rugogo switches off the whole Western Uganda just because someone is climbing on the pole. Okay? So that is emergency shutdown, emergency procedures. We have documentation, maintain detailed records and maintenance activities and safety measures implemented. We have regular safety meetings. Hmm? I know some of you have done internship with Gumeme majorly. Every morning you must go on that meeting. It's a safety meeting. They have to keep reminding you that you need to put on your PPE. You have to be careful. You need to follow procedures. We come to safety measures during maintenance. We have permission, a work permit. Now, a work permit, I'm just to talk about it. When you're doing any kind of maintenance, you're not supposed to go on a live line. You need to get permission. You need to get a work permit and follow all the procedures. A working permit is provided by an engineer. Because in different companies, now here like in Umeme, they call them technical officers, TOs. There is a TO who is responsible for a certain period, is responsible for switching off and switching on. That is the person who delivers the working permit. When you are going, for instance, to do maintenance at Chumuru on a transformer, he has to go to the power station, switches off, clears the line off, and brings a permit and gives it to the person responsible, maybe the senior linesman, to show that there is no power in the line. Then us guys will start working. There is something I didn't talk about, which we should know about as engineers. There is what we call roto. Lockout and tag out. This one we need to know it. After isolating, even if it is a power substation, the guy goes on the panel that has switched off the Chumoro line or the Chumoro feeder and puts a plate under maintenance. He puts a tag. For those ones who have ever gone into a substation and you have ever seen how they do switching, after the guy has switched off, he puts that tag that it is under maintenance. Otherwise, someone may call and complain that the whole power is off. Then another person comes and puts on. But when you find a tag out, you have to put a tag that this line is under maintenance. That is tag out. Very, very important to note. Very important to note because I was about to die on the line because of some carelessness of some people when I was doing my industrial training. Someone put on a generator because we had a permit, we were working, and then some other guy from a certain company that I will not speak here put on a generator and failed to change over. Okay? Change over from the grid to generator. And then the young man who was up, the power came back into the lines. But it was God that we are still alive. So we have to be very, very conscious about safety when we are doing maintenance. Okay? That is the working permit. For you to do work, you must be authorized and by an engineer who has to bring it and say, it's me who has put off the power. Now the line is safe. You can start working. Still, even before working, you yourself, you're supposed to test the line and know, is there power? But they don't test an HV line of 11 or 33 with our phase testers. No. There is a tool called, HV. You guys, you can write this, you can search about it. It is called an HV proximity. HV proximity tester. HV proximity tester. You can write it and search about it. That device is put on what we call an operating stick and raised up to the when it makes noise, it means power is still in the line. But when it doesn't, then it means yeah, the guy has put off power, and therefore you can start working. Okay. I have evidenced this about safety. Some two guys climbed a rotten pole which was not inspected. Mm. They fell down. One died on the spot, and we buried him in Tungam. Another one broke both arms. I evidenced that myself. So when we are talking about safety, you don't know when an accident is going to happen. When I was starting about safety, I talked about the PPE. They are high voltage gloves and they are low voltage gloves. No matter whether you have the permit and you're working on a line, you're supposed to be cautious about PPE. Make sure you have the gloves. You don't know what may happen. When you are climbing the pole, you climb in the safety belt, make sure it is on, but some people want to make themselves seniors, they climb without the safety belt. And that is not right. Okay? We have from safety, we now go to electrical power distribution maintenance. Continued. We have overhead maintenance. Before maintenance is done, the lines and equipment should be inspected by a competent person. We don't just go to do maintenance. I told you there is what we call a planned maintenance, and there is what we call an emergency maintenance. We have planned, we have emergency. Emergency now power that is supplying Mbara hospital is off. What happens? That is emergency. You have to rush. Even if you are going to Ntungamo to work on something, you have to first work on the hospital because that is critical. Emergency. Planned, you have to first go and do inspection. Then you bring the results and say, this is needed, then the team can go. We are talking about inspection. The following points need to be taken care of during inspection. Make sure the proper clearance is obtained. The line is different. I talked about ground clearance. That's why they are talking the distance between conductors and the ground for different voltages because the one for HV is not the one for LV. Adequate safety and clearances. Still, they are talking about clearance. So that means it is very, very important. When the conductors are sagging, you report. Then they come and string them. And there should be an appropriate earthing. There is what we call multiple earthing. On every pole, there should be earthing. But because it is expensive, they always make earthing like on every 3 poles. But it is a must. There is what we call a terminal pole. Now, a terminal pole is that electricity is being distributed and the last pole is at your house. That last pole, like power is not continuing, it is ending from that pole. It is a must to earth it. You will always see some wire, some small wire running from up down. Because if it is not earthed, the lightning will just burn it immediately. Proper cross arms, extension cross arms should be ensured. Cross arms, I told you, those are the metals where the pin insulators over which conductors run on. Tree cutting should be properly executed. When the trees are growing and you see they should be cleared, sagging of lines should be minimized. That is to maintain the ground clearance from the distance from the conductors to the ground. Leaned poles should be rectified. There are poles that lean, maybe because of environmental factors, rain. You should report they come and rectify them. And rectifying a leaning pole I think they call it replumbing or replumbing. Pore replumbing or pore replumbing. You can search about it. It is also an activity that we do during maintenance. Raising cleaning pores. Lines should be properly aligned by tightening with proper bolts and nuts. I told you about the bolts. Earthing should be checked always. Torn insulators, flash over insulators should be replaced. When a pin insulator that is supposed to be isolating the 11 kV the conductor that is passing on the top is torn, that means that there is a likelihood of dying, of killing very many people. And therefore, it is very important to, uh, to check these insulators. Jumper wires. I talked about jumper wires. They should be checked. They should not run or cause short circuit. When you look at jumper wires, some jumper wires, they are always leaning and about to touch the other phases. So they should be checked also. Stay wires should be properly aligned. I talked about stay wires at the beginning, and therefore they should be tightened to the recommended tension. And there is a tightening accessory on it. It is called a turnbuckle. When it is not tightened, it can be tightened. Okay. We have overhead line maintenance. Overhead line maintenance is required to minimize interruptions and improve efficiency of power supply. The overhead lines should be inspected periodically to detect any fault which may lead to breakdown of electric supply. When an overhead line trips, it should be inspected to find out the nature of the fault. Now, when we talk about fault, you see this distribution, it has a lot of things, and we cannot talk about them and finish. We have what we call asymmetric. We have what we call asymmetric faults, and we have symmetric faults. Now, symmetric faults, it happens on three-phase, three-wire. If I can remember well, three-phase, three-wire. Whereby the three-phase, both three-phase are short or they connect. Let me talk about it so briefly. If we have something like this, guys, pay attention here. This is A, B, C, already blue. A, B, C. Symmetric, we mean this. Three-phase, three-wire, shorting. This is Z, ZA, this can be ZY, ZB, this can be ZC. So when these three phases, the 11 or 33, the ones I told you at the beginning, or 33, when these wires short together, that is what is symmetric fault. But when these wires short together and again they connect to the earth, it is also another type of symmetric fault. You must know that when they short, they have what we call balanced fault currents. Okay? Balanced fault currents. Then for asymmetric, it happens in low voltage. If I can remember well, let me hope I'm not mixing them. Asymmetric in low voltage. In low voltage, you know, we have three-wire, we have three-phase, four-wire. Now there we talk about two phases connecting together, and the other phase remains not connected, and the neutral remains not connected. All the two phases connect together, as I've said, and they connect to the ground. That is a symmetric fault. I was going to finish this without talking about faults. Then under these faults, we have what we call open circuit faults, and we have short circuit faults. Those names describe them: a short circuit and an open circuit. An open circuit, that means that the phases are just open. They are not connected. Okay? Maybe they are isolated, And that's why we are finding out why. Why is power not reaching the other side? Then we have what we call short circuit. Short circuit is these things that I'm showing you. When these short together, that is a short circuit. And in that there we have a maximum current and almost zero voltage. Okay. So we have activities performed during overhead maintenance. We have alignment of poles. I talked about this. That is pole reprimbing. We have replacement of damaged service wires. Service wires, these are the wires that supply to our buildings from the transformer. We have removal of bad nests. We have tree clearance, checking the pole setting, careful examination of damages and conductors such as black spots and conductors. Okay, all those are the things that we do. We have ground patrol, the periodic patrolling exceeding a month of overhead lines at ground level. While the line is live, it is called ground patrol. Pole to pole inspection, poles maintenance. That is, the line is live. We have the following should be checked. Leaning poles, I talked about the leaning poles, sinking of the earth around the pole. Okay, sinking of the earth around the pole. You find that the pole is about, no matter how straight it is, but there is sinking yeah, of the earth around the pole. Here you find that the pole is moving down, or you find that the soil that is on it, maybe I don't know whether it's because of animals or environmental factors, but it is sinking. Okay. Then we have stay wire. I talked about stay wires. Okay. Corrosion of stay wire. Okay. When they are rusting, we have to check them. Stay wire tightness. They should be tightened to the recommended tension. We have availability of insulators. Availability of insulators on every stay. This is not there. Every stay should have what we call a stay insulator. That one isolates any fault up from reaching down. Because you realize oftentimes you guys will be leaning on those supporters or stays. So in case there is no insulator, then people can die. So availability of insulators on every stay, they should be checked. Cross arms, I talked about cross arms. These are the metals. So tilting of cross arms, rusting of cross arms, bad vests, all those are the things they do in maintenance. Okay. Finally, before time gets up, let me talk about an air brake switch, which is very, very important. Now, when we are isolating, maybe we want to work on a certain line, but it is radio. Imagine we are working on Ntungamo feeder. Ntungamo is from here in Kashanyaras. That is where its feeder comes from. It goes from Ntungamo. Now for you, you are in Rwampara, but you want to switch off power from Mbarara. That means you will affect, we shall lose revenue, and people, the activities will be on a standstill. So there is always this air brake switch. This one helps in isolating HV, that is 11 kV or 33 kV. If you want to know this air brake switch, when you are coming out of our gate in Chumro and you are reaching the main road, from the gate, on your right hand, this thing is there. There is an air brake switch. You will see that thing. It is like a transformer up there, like a small transformer. On your right hand side, you will see it. This one it helps in isolating, because there is no how you can isolate 11 kV or 33, such that other people remain with power, but for you, you work. So these air brake switches are put in specific places for that purpose. Otherwise, the other way you can isolate 11 kV is from T-offs. There is another terminology which I didn't talk about, T-off, and they are always what we call high tension fuses, HT. high tension fuses. Also, high tension fuses can help in isolating. But what we are talking about air brake switches is to check all these things to see if they are working. Because the moment there is an anomaly in this air brake switch, you go and you switch off, you isolate, you think you have isolated, then you go to work, many people may die. And therefore, it is very important to make all these maintenances you see here. Okay? Damage of the earth wire, dust accumulation, blades, contact burning, all those should be checked and done. Maintenance done on electric poles are inspected, visually checking its sounding. This helps to find out rotten and leaning poles and any other dysfunctionalities. This is the last one. Talking about poles, I'm telling you, I evidenced one person dying. Yeah? They were two climbing without the pole because we test the pole by sounding. You see, checking its sounding. You beat it and hear its sound. If the sound is like the one of a ripe jackfruit, then that pole may be rotten, and it is very important to take caution of it. But when the sound is solid, then that pole is still active. Okay. So evidence a person dying, they climbed on a pole, it was rotten, it fell down, and the guy died in an instant. We buried him. The other one broke arms. So when we are talking about maintenance, you should pick something at least such that it helps you in future.